In this tutorial, you will be able to create automated generated levels via code. If you like tutorials like this, just leave a like, and if you want to see more tutorials, then just subscribe this channel and let's go. We start by creating a new file, which is room, and it inherits as from object, and we give this one a class name, and this one is room. We use this object for defining a few variables which will store the data of each room. So we have two variables here. The first one is position, and which is in vector to I, and we also have a variable which is size, which we also call as a vector to I, and the last one is a function where we get the center of this room, so which we just call get center, which will returns also a vector to I, and then we say return position plus size divided by 2. So that's actually it. We save it, and then we have new class. The only adjustments we have to do is in the world script. We need 4 variables and 8 functions, and then we also then we already have automated generated. Then we have automated generated and auto. Then we have procedural creation of levels. So the 4 variables we have is dungeon size, max room, rooms, and grid. Dungeon size is an int. In my case, you can also use a vector too if you want to have different lengths and width and height of the dungeon, but I use the same, so I will have a square. I predefine it by 100. Then we have variable which is max room, which will tell the level generator to just have a maximum amount of rooms in this dungeon. We set it to 20, and we have variable which is rooms, where we store an empty array at the beginning, and also a variable where we store the grid, which is also array and also empty at the beginning. We will start by adding a function which we call generate wall, generate, and there we say for y in dungeon size, then variable row array equals empty, and then we say for x in dungeon size row dot append 1, and then we say grid dot append row. So what do we do here? We generate an array for each number which is from 1 until 100, and there we create a row which will append this array with the number 1, which will fill a whole array with 100 numbers of 1, and this array will be filled with 100 arrays which is filled with 100 number of 1. The next function we do is generate room, which will delete the ones of this arrays to create space in this arrays for the rooms. So we say generate rooms void, and we say variable tries, because this variable we'll use to when the dungeon creator is not able to create 20 rooms on this map, that we have at least a limit of 100 tries to create this 20 rooms. Otherwise there will be less than 20 rooms in this dungeon. So the while loop we will use now will always have an end, otherwise the while loop will run unlimited. It will probably crash your engine. So while rooms size is smaller than max rooms, so in our case 20, and tries is smaller than 100. So we have 100 tries, and if the function is not able to create 20 rooms in this time, then we have 19 or 18 or less rooms. So we create 5 variables here. 4 variables here. This is width, int equals randy range. Here we create a minimum and maximum width of a room. So I say 6 and 16. I already tried this before. I think this is the best range for this size of map. Then we have height. Here we also say equals randy range 6 and 16. Then we create position x int equals also a randy range, but here we say from 1 until dungeon size minus width minus 1. So for example, when the room is 16 miles big, then it will put the maximum dungeon corner, which is always the left top corner, with a border of 1. So each room will be inside a border of minimum 1 wall, so that the player doesn't have the opportunity to just leave the whole map. And the same thing is we do with position y. Int equals randy range 1 dungeon size minus height minus 1. Okay, this won't work when I don't say make rooms here, otherwise we will not make this work. The next thing is we need to generate this room. For this, we need a new room, and we use the class we just create. So we just need to say room dot new, and then we say new room dot size equals vector2 I. The difference between vector2 and vector2 I is just that vector2 I has only ints, and the vector2 can have ints and floats, but most likely they'll be displayed as floats. So here we say just like width and height, and also new room dot position equals vector2 I pose x and pose y. Now we make a check. If not check room overlaps new room, then continue. But if this is the case, we say rooms dot append new room tries plus equals 1. So what do we do here? We check first if check room have overlapping other rooms. So if this is the case, we'll just skip the append, but we will add the try. Okay, what does this function do? If not check room overlaps new room, then here we add a try because this one is a failed try. And then we continue and skip this append and also this try, addition to the tries. And then the while loop will just do another loop and try to check if there's another room will overlap. And if this is not the case, we will add this room to our map. So that this will not have this error anymore, we need to create this function. So we just say check room overlaps, and then we add a new room. So we say room A is room, and this one will leads to a bool. That means whenever this function is finished, every end of this function will lead to a bool, like true or false, but it cannot be anything else. So this one will be always true or false. So we need to check for room B in rooms. So we'll just check this array, which is filled with rooms, if one of this has the same chords like our room A. If rect2 room A dot position plus vector 2I minus 1 room A dot size plus vector 2 1 1 vector 2I 1 1 dot intersect. Here we say similar just with room B, rect2 room B dot pos plus vector 2I minus 1 and room B dot size plus vector 2I 1 1. And if this is the case, we'll just return false. But if they are not overlapping, then we just say return true room underscore B. And this return true has to be on the same level like the for loop. So if it can't find a room in this array which overlaps with room A, then it's true and we can add this room. Otherwise, when it's overlapping with a room in this array, then it will return false. So what does this do? Rect2 will create a new rectangle, which will always start at the top left corner. This is the position from room A, for example. And we put -1 because I want that the rooms will always have minimum one tile as a wall between them. Otherwise, it also counts as overlapping. That's why I add this vector 2i to the position and also this vector 2i to the room size. The next thing what we are gonna do is that we erase the rooms from this grid. So we say function erase rooms voids. And we say for room in rooms, for x in range, room dot position dot x under room dot position dot x plus room dot size dot x. We say for y in range room dot position dot y under room dot position dot y plus room dot size dot y. And we need to say grid brackets and here y x equals null. So this function turning every one on these positions from this room into 0. That means later the tile set will just turn them into space where the player can walk, and every one which will be left will act like a wall. So now we have rooms, but what we also want to have is that the rooms are connected with a way. And this one we're doing now. We have function connect rooms, which will lead to void. And here we say for I in range 1 under rooms dot size So for each this array, we will connect it with the next generated one and not with the most nearest. There will be also a way to connect them with the most nearest. It is by sorting this rooms array before you will call this function, but we'll do it with the unsorted version, so it will be a bit more randomly for the player to play it. So we say for I in range, we'll create two variables. This is room a center, which is in vector 2i, equals rooms I minus 1 dot get center. Here we call this function we just created in the rooms class. And then we have room b center vector 2i equals rooms I dot get center. This is the start and the end position from the way we want to create from room A to B. And we do if randy. So we have two different types. So the first one will go like up and then to the right. And the second version will go right and then go up. So we have a bit more variation of ways that will connect the rooms. So we just say simply if randy is 2 equals 0, 0. So here we will call two functions, but this one we don't create yet. So we just write past it now. And we will fill them later inside here after we create these two functions we need now. The first one is to erase the horizontal floors. And the second one will be for do the vertical ways. So we say first horizontal way. And we need room A center x as an int. And we need room B center x also as an int. And the last what we need is room A y axis also as an int. And this will also be void. So for x in a range. So now for each x in range, minimum room A center x, room B center x, and then we say max room A center x and room B center x. And we add them to the grid. So here we say room A y axis and say x and equals 0. And we also say room A y axis plus 1 and we say x equals 0. If you want to keep your ways just one tile size, then you don't need to write this function. And the same thing is we need to create this one for the vertical way. So we say raise vertical way room A center y as an int, room B center y as an int, and room A axis as an int, and also to void. And then we say for y in range. Actually we need the same like here, so we say minimum is room A center y, room B center y, max room A center y, and room B center y. And we also need to say +1. Don't forget the +1. Also here +1. And we say grid y, and here also the same room A axis equals 0 and grid y room A axis +1 equals 0. So these two functions we have to just add here. So we'll copy this one, put it here, and then it wants from us 3 variables as a flag. So what we're gonna do is we send room A center dot x, room B center dot x, and also room A center dot y. And we also do that for the erase vertical way. Now here we send over room A center dot y, room B center dot y, and room B center dot x. And here we do the same thing, and here we have to do the same, just exchange the positions of both and horizontal afterwards. And here we need to send room B, and here we need to send room A. So room A center, room B center, and room A center in the first, and then room A center, room B center, and then room B center. The last function we need to create is to actually cut this out from a tile map. We call our tile map wall, and we also have it revoke unique name. That means we can just call it from this script with the person sign beforehand. And this is what we're gonna do now. We say function set wall tile map. We say for y in dungeon size, for x in dungeon size. If grid y grid x equals 1, we'll just say %wall dot set cell, and here set cell is an inbuilt function from tilemap layers. So here we need to put the chords, which is vector to I, and here we need to put the x and y. The next source ID, in our case it's 0. So when you check this one, just imagine this one is an array 0 1 2 3 4 if you have multiple pictures. So this one is our source ID 0. The next what it wants is atlas chords, which is the chords of our wall on this tilemap. Our tilemap has just one, so we can see here atlas chords is 0 0. So we put here vector I 0 0. And the last thing what it wants from us is alternative tile. I don't have alternative tile. The only thing what we need to do now is to call all this function in the right order. For this we're at the ready function, and here we say first generate walls, then we say generate rooms, then we say erase rooms, then we say connect rooms, set wall tile map, and the last one is that we want that the player's position is always in the center of the first created room. So we say global data dot player dot position equals rooms 0 dot get center, and this center we need to multiply by 16. So because this center would be probably something, for example 6 and 8, but 6 and 8 is just the position of the tile, but our tiles has a size of 16 by 16, so we have to multiply this number that the player will be at the right spot. And if we do everything right and we start the game, we have an automated created map here. So we have this one, it's a big map with a lot of ways, and if we start it again, we have this map. So it always will generate automatically different kind of maps. You can just adjust this numbers here a bit. So for example, I can just say we added 10 rooms, and then the whole map will looks like kinda like this. If you like tutorials like that, you can leave a like. If you have any questions regarding this map generation, just leave a comment, and if you want to see more tutorials like this, then just leave a subscription to the channel. It will help me a lot, and I hopefully see you in the next video.